The first definition is a frequency distribution or frequency table. A frequency table shows how data is partitioned among all of several categories or classes by listing all of the categories along with the number of data values in each category. I make a frequency distribution every time I give a test and I grade those tests. I list how many A's, how many B's, how many C's, how many D's, how many F's. Or I could break it down into numbers. My first class would be 90 to 100. My second class would be 80 to 89 and so on. And then I just tally up how many grades are in each group to see overall how the class did. So that is a very quick example of a frequency distribution. When you look at this data, pulse rates of females and males, I can't make any sense of that data. I mean, it's just a bunch of numbers. I don't know what the numbers mean. I don't know, well, I know what the numbers mean. They're pulse rates. But I don't know if the males and females in this group had a high pulse rate, a low pulse rate, an average pulse rate. You can't really get a picture of the distribution of that data without organizing it somehow. And a frequency distribution is one way to organize it. This is a frequency distribution of that data. These are called the classes, 60 to 69 beats per minute, 70 to 79 beats per minute, and so on. And then somebody just went through that list of data and using tally marks, just put a tally mark every time they found one of the data values lying in each class. And at the end, just count up how many tally marks are in each class. When you look at the frequency distribution, you have a much better understanding of what that data is telling you. Most folks' pulse rates fell in the range of 70 to 79. Second most was 60 to 69. So at least for this group, if not for the entire population, because we don't know if this group is representative of the entire population or not, but at least for this group, the vast majority had pulse rates between 60 and 79. Very few had pulse rates below, not below, but above 90. Very few had pulse rates above 90. So it's just a way of organizing information to make it easier to understand. Now, here are the terms that you need to know about frequency distributions. The lower class limits are the smallest numbers that actually belong to the different classes. So these are your lower class limits right here. The 60, 70, 80, 90, 100. Your upper class limits are the largest numbers that can actually belong to different classes. So the 69, 79, 89, 99, and so on are your upper class limits. Those words make sense. Lower class limit, upper class limit just tells you the boundaries for each class. And then there are class boundaries, the numbers used to separate classes, but without the gaps created by class limits. Every pulse rate listed on that original table fell into one of these classes. There was no pulse rate that was, say, 69.5 because nobody can have half a heartbeat. But if we were going to make a graph of this information, it might be helpful to have the numbers that are separating the classes, maybe the average of an upper class limit and the next lower class limit. The average of 69 and 70 would be 69.6. 69.5. So 69.5 would be a good demarcation between those two classes. 79.5 would be directly in the middle of those two classes, 89.5 between those two classes. Those are the class boundaries that we would probably use if we were making a histogram, which we're going to talk about in a minute. Notice that you always have one more class boundary than you do classes. Think of these class boundaries as fence posts. separating the classes. This frequency histogram has, or not histogram, frequency distribution has 2, 4, 6, 7 classes. It has 8 boundaries because you have to have a left fence post and a right fence post in addition to the 6 fence posts between classes. So anytime you're listing the class boundaries, you're going to have one more class boundary than you have class because of that left and right fence post. Class midpoints are the exact middle values of each class. You can find a class midpoint just by adding the upper and lower limit of each class and dividing by 2. It's the average of 60 and 69. The average of 60 and 69 is 64.5. So that's the first class midpoint. And similarly, did I say 0.9? I didn't mean 0.9. I meant 64.5, but I'm not sure what I said. I just thought of something you may want to write down on class boundaries because I didn't type it for you. If you want to make a note about how to find the class boundary right here, let's see, the best way to word it, add an upper limit of one class and the lower limit of the next class, and divide by 2. What's happening? Did you find this slide?
No, I've got 2.1 terms. So I'm trying to figure out.
That is tomorrow's. That's not even today's. That's 2.4. That's 2.4, so just pull that out. I'm not sure how it got in there. No, it's okay. Stop it. Stop apologizing. Yes, yeah, no, it's okay. You add an upper class limit to the lower limit of the next class and divide by 2. Which really makes sense if you think about what boundary is. It's halfway between one upper limit and the next lower limit, halfway between 69 and 70, halfway between 79 and 80, halfway between 89 and 90. That's what the class boundaries are. All right, I just realized that I had not typed how you find the class boundaries. I did type how to find the class midpoints. Just add the lower and upper limits of a class and divide by 2. Again, because you're looking for the average of 2 numbers. The class midpoints, they're in red. And the class width. The class width is the difference between 2 consecutive lower class limits or 2 consecutive upper class limits. The difference between 60 and 70 or 69 and 79. We would say these class widths are 10. As if I were tallying up grades on a test, I would use 90 to 100 for one class and 80 to 89 for another class, 70 to 79 for another class. Each of those would have a class width of 10 points. Yes. Yeah. Class midpoints are smack in the middle of each class. So you're going to have the same number of class midpoints that you have classes. The class width should be the same for every class. It's the class boundary that you're going to have more of. And if you think about the fence post, got to have one on the left, one on the right, and then those in the middle, you'll see why you have to have one more class boundary than the number of classes. All right, constructing a frequency distribution. Here are some steps, and then we're going to practice it. Determine the number of classes. That's up to you, but it'll depend on how spread out your values are. If I have grades from 0 to 100, it makes sense to divide that up into maybe 10 classes. Maybe I don't want to lump all the Fs together because there's a big difference between a person who made 55 and a score of 15. So maybe I'll use 10 classes and tally marks for everybody who made 0 to 10 and 10 to 19 and so on. Determine how many classes should be between 5 and 20, just because if you have 100 classes, that's going to be as difficult to make any sense of as the original data was. That's just too many classes to really get an image of what the data looks like. The class width, just think about test scores again. The highest test score minus the lowest test score and divide by the number of classes. If I decide, if I have grades from 0 to, well, let's say I just have grades from 10 to 90, then the range of that data is 80, which you get by subtracting the 10 from the 90. If I've decided to make that into 9 classes, I would say 90 divided by 9, and my class width would be 10. Choose the minimum data value or a convenient value below it as the first lower class limit. If I had scores from 10 to 90, then 10 would be my lower limit of the first class. And then to get the lower limits of all the other classes, you can just add the class width. List the lower class limits in a vertical column, proceed to enter the upper class limits. And then just start tallying into which class each data values fall and count up your tally marks. Let's do an example because that makes much more sense. Let's make sure you understand the terminology first. You have some problems in the homework that just say identify the class width, the class midpoints, the class boundaries, and then you have some where you actually have to make the table. This first problem gives the weights in pounds of discarded plastic. I think that is maybe per household per week. And the frequency would be the number of households who had that many pounds of trash per week. So identify the class width. That's just the difference between each lower class limit or the difference between each upper class limit. What's the difference between 0 and 1 pound of trash, or 1 pound of trash and 2 pounds, or 2 pounds and 3 pounds? Just 1. So the class width is 1. Units always make more sense. I don't think they'll ask you for the limits in my math lab, but that does make it clear that you understand what it is we're talking about. The class width is 1 pound. Class midpoints, how many classes do I have here? 6, so how many class midpoints? 6, because each class has a midpoint. There's something exactly halfway between 0.00 and 0.99. Something exactly halfway between 1.00 and 1.99. How do you find the class midpoint, say, of this first class? Yeah, you're looking for smack in the middle, the average, add and divide by 2. So 0 plus 0.99 is just 0.99. 0.99 divided by 2, 0.5. This doesn't do so well in my head. 0.495. Isn't that right? 0.495 would be the first class midpoint. And it's right here. That's what we're talking about. Halfway in between the lower and upper limits for that class. Now we could continue doing that. For the second class, we could add 1 plus 1.99 and divide by 2, then 2 plus 2.99 and divide by 2, but you don't have to. If you know the class width is 10 and the first class midpoint is 0.495, what's the next one going to be? 1.495. Did I say the class width is 10? I need to just slow down and breathe. Class width is not 10. We wrote 1 right here. I'm just saying 10. Sorry. The class width is 1, so just add 1 to get the next midpoint. Add 1 to get the next midpoint after that. The second midpoint would be 1.495. The third midpoint would be 2.495. Go ahead and list all 6. Let me write them down and then you ask that question. 0.495, 1.495 is the midpoint of the second class. 2.495 is the midpoint of the third class. 3.495 is the midpoint of the fourth class. Then 4.495 and 5.495. Yes, ma'am.
Okay, so when you're trying to get the midpoint between 0.000 and 0.99, would you begin adding it at 0.01?
No. Let's think about easier numbers for a second. If I was going to use from 80 to 90 for one of my classes when I was tallying up grades, I would just add the 80 plus the 90, which is 170, and divide by 2. 85 would be the class midpoint. All right. So you just add the lower limit to the upper limit for each class and then divide by 2 to get what's exactly in the middle of the upper and the lower limits. All right. But you need to have the mental image of what a class midpoint is. It's exactly what it sounds like. It's smack in the middle of each one of those classes. And then the class boundaries are the fence post between the classes. How can I find what's exactly halfway between 0.99 and 1? Add and divide by 2. That's how you find the average of any two numbers. 0.99 plus 1 is 1.99. You can think of this as 99 cents and $1. What would be halfway between 99 cents and $1? Well, yeah, 99.5 cents written as a decimal would be 0.995. So that's one of the boundaries right here. 0.995 separates those first two classes. And you could continue adding the upper limit of one class and the lower limit of the next class and dividing by 2. But you don't have to. Again, if you know the class width is 1 and this class boundary is 1.99 or is 0.995, what's this fence post going to be? Yeah, 1.995 is halfway between $1.99 and $2. 2.995 is halfway between 2.99 and $3. And 3.995 and 4.995. However, if I'm building a fence to hold in these 6 cows, how many fence posts is it going to take? Not just these 5 that separate the cows, but got to have one on the left and one on the right. So just go back one more and up one more. What would be one before 0.995? actually be negative 0.005, and it doesn't make sense to talk about a negative pounds of trash. So for this left fence post, you would actually just use 0, only because a negative pounds of trash doesn't make sense. If this were temperature, I could go back to a negative. And what should this right class boundary be? Well, the distance between the class boundaries need to be the same. So if the last one we had was 4.995, the one on the right would be 5.995. So the difference between all of these class boundaries is 1, except for this one on the left, because it didn't make sense to talk about a negative. And that's the 7 fence posts it would take to separate those 6 cows. And I'm not going to rewrite all those class boundaries, but it's that list.